Good evening, good morning, because I'm still in the other time zone. My name is Peter Van. I'm innovation leader at SWIFT, which is the network of the banks. So we operate a network of interbank transactions in 210 countries worldwide. We push through about 20 million transactions per day, and that has a value of about $6 to $8 trillion per day. So the network that we operate is a critical component of the infrastructure, and our mantra is failure is not an option. So innovation in an organization that is doing failure is not an option is quite a challenge. And I'm going to talk to you about a project that is called the Digital Asset Grid. This is a research project that we executed over the last 18 months together with worldwide experts on personal data sharing. I start with an expression of who am I? I'm not going to give you my CV or my bio, and it's not going to be a philosophical discussion about your personal purpose in life or something like that. But what I try to convey here is that every human being is born as a baby, and as a baby you're already born in a certain data context. So there's something going wrong here. So in a certain data context, and that context can be your financial context, or that context can be all sorts of conditions that you live in. It can be your family, it can be ancestors, it can be your government. So every person is born in a certain country. And I was born in the middle of Brussels, in Belgium, and in Belgium we have something called an identity card. So I have this identity card with me as a prop. So it looks like a credit card, and it has a chip in it, and in that chip are two certificates, one for digital signature and one for authentication. And so this is a government certified identity that can be used online with legal framework around it. So when Bill Gates, my previous employer, saw this card, he said, wow, that's interesting for government, that's interesting for Windows, so I'm going to become your executive sponsor. So I had the pleasure to work directly with Bill and start thinking about what does digital identity mean, what sort of applications come into the market, what are people wanting to do on their computer, on their mobile, on their chat, what do we want to do for child protection and that sort of things. But it's a card, and in my opinion, that EID card has become an anachronism. The problem is that we have started using brick-mortar concepts, such as an identity card or a passport, and try to apply them to a very multidimensional world, which is the online world. So we can do several things. We can stick our head in the sand, or we can try to think about a better way. And there must be a better way, and the better way that I'm suggesting is to start thinking about identity like a spectrum. Like you have a spectrum of a star. A spectrum of a star is unique. Yeah? So what you see here is the output of a project of MIT. It's a research project at MIT. It's called Personal Data, Personas. And if you enter your name in there, it's going to search on the internet what is your footprint. Looking at the previous speaker, Joanne, she talks about the breadcrumbs that you leave on the internet. So this is what this application is doing. It's going to fetch your data and categorizing them in a spectrum. And so each color in this spectrum represents a certain facet of your identity, whether that's a business aspect or a personal aspect or a health aspect, etc., 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 etc. So when I was much younger, I have done all sorts of crazy things, and one of the things was I was a DJ, and I was a founder of one of the first pirate radio stations in Brussels. So radio is still close to my heart. And one morning I woke up and I was thinking about these old radio stations. For some of you who may remember, these had a big button and it had an arrow so you could tune into the channel that you wanted to listen to. And I started thinking, geez, what if I would have a sort of radio station so that I could tune into the spectrum of my identity? And not only tune left-right on this spectrum, but also zoom in and zoom out. And what if I would add the aspect of time? Because my identity is different now than it is in 5 minutes, because I left different breadcrumbs. So I was getting into something multidimensional. I have this sphere here with all the colors of my identity. So imagine that you would have a sphere around you with all the colors of your identity, and you, as a user, you can select which colors, which facets of your identity you want to share with service providers in a particular transaction context. I came across a gentleman in this research, a gentleman called Doc Searls, S-E-A-R-L-S. Really Google him. He is the inventor of the concept VRM. VRM is the opposite of CRM. So every big company has a CRM system. And what do you do with that CRM system? You try to get better insights of your customers so that you can better target services or advertisements to those customers. Watch the wording. It's about sending ads, shooting ads at the target. It's military language. It's a relationship between the service provider and the end user, which is a master-slave relationship. There is an unfairness in that balance. So VRM is the opposite of the CRM. VRM is a set of tools that would be at the disposal of the end user so that the end user can decide which aspects of their sphere they want to share in what context with what service provider. So in this context of this setting here in the AMP building, start thinking about the service provider as being AMP. So me, I want to share certain aspects of my spectrum with AMP in the context of specific transactions. The big aha moment that we have in this 18-month research is when at a certain moment we realized that this is something we may not only do for personal data, but maybe this is a model that would apply for any sort of data. Any piece of information that's digitally represented. So if we start combining the VRM concept with the sphere, then I'm getting very close to one of my heroes, Mr. Buckminster Fuller. And I have a little video from Buckminster Fuller, how he thinks about ecosystems. So here goes the video. Is it playing?
The man behind it was a utopian visionary who had worked as an engineer in the US military. He was called Buckminster Fuller. "I will make my life an experiment," he said, "to search for the principles that govern the universe." Fuller had invented a radically new kind of structure that was based on the underlying system of order in nature. It was called a geodesic dome. It was very simple but incredibly strong. Giant geodesic domes were built to house the radar installations for America's early warning system in the Arctic. Fuller's geodesic domes imitated the idea of the ecosystem. Each tiny strut was weak, but when thousands were joined to form a giant interconnecting web, they became strong and stable.
Each tiny structure was weak, but when they started to form an ecosystem together, they became something strong and stable. So there are different ways to look at the project called Digital Asset Grid. One way is as a solution for what is coming, is what I call the catastrophic complexity, which in my opinion is caused by two things. So the first thing, it's about the number of nodes in the grid. What you see here on the left-hand side of this slide, left-hand side of the slide, is a highly simplistic model of the SWIFT messaging model. Bank A and Bank B send payment transactions from A to B, and that goes over a central hub. And that central hub is, of course, for resilience reasons, they're mirrored in different operating centers in the world, but that's the basic model, A to B over a central hub. What the digital asset grid is proposing is a fundamentally different model where A and B are sharing data in a peer-to-peer mode without a central hub. So when you have only two nodes, that's pretty straightforward. But what if you have hundreds, thousands, millions, trillions of nodes on the grid? Joanne was referring to the Internet of Things. So that's what we are thinking about here, the Internet of Things, where those nodes, all those different things, are not only human beings, but can be groups of human beings. Like a Google circle is a good example of a group of people online, and that group of people does not have a legal entity. Another group of people is a company, a corporation for profit, which has a legal entity with liabilities associated to it. Another group of people is a not-for-profit organization. But it's not only people and organizations, it's also devices that have an identity, programs that have an identity. In our business, algorithms that do trading have an identity. So if we start mixing all those identities, we really have an explosion of the number of nodes on the grid. So we at SWIFT, we have currently more than 10,000 banks on our network, which is great, but managing 10,000 nodes versus 1 trillion nodes, it's quite a different ballgame. The second change that caused the catastrophic complexity is this image of the camel in the ocean. I mean, there are always some smart people in the audience that says, Peter, this is not a camel, it's a dromedaris. Yeah, but it's easier to say the camel in the ocean. This is probably the most important picture of my whole presentation. So before, the camel walks in the desert, and on his back, he has the water. So the water is a metaphor for data, and the camel is a metaphor for the enterprise. So we are used to think about the enterprise, the bank that is carrying the data of their customers in the desert. What's happening now is that the camel is in the ocean. The camel is swimming in data. It's overwhelmed by data. And I believe that we need a different sort of species of organizations to be able to survive in that abundance of water of data. So if we bring the two together, number of nodes and the camel in the ocean, we have cooked up this idea of a digital asset grid, which is represented by the blue sort of blue shape. I mean, it's very difficult to read on the screen. And above that shape, you will see a little box, and that's an API layer, application program interface layer. So that would be exposed through APIs. And banks and other institutions could start offering services on top of those APIs. It's one way of looking at this concept. Another way, so I have to add something important here. So if you do P2P, peer-to-peer sharing between nodes in the grid, you have to start thinking about the trust model that is underpinning that. Well, at SWIFT, we have some experience with putting in place a trust model. We have done this now for 40 years. So we think that we can bring over all the goodies of that trust model into a peer-to-peer model. And it's about things like governance. How do you govern a community of thousands and millions of nodes? It's about identity. It's about security, the rules of the game. What are the rules of the game in this community? It's about, there's something going wrong with the clicker. Probably stand a little bit closer. It's about creating a trust framework. It's about defining liabilities if something goes wrong. It's about change management. How do you change 10,000 banks from one version to another? It's about operational excellence. All those things bring together trust in the community. Another way of looking at this project is from a more technical side, where you have this concept of the digital asset grid, which in essence is a map of where the data are located, what are the rights associated with those data, and who can benefit the rights on those data, and what's the associated trust model when you start exchanging data in that context. So we bring it all together, and what we in essence are creating is a pointer infrastructure, where the pointers are saying, this is where the data are located. It's basically a URL, or a URI, if you want to be specific. And it also says, and here's the place where the rights on the data are positioned. On top of that, we have an API layer. And you have to look at this as a sort of map. Like you have the Google map for physical buildings. What we have created is a map for digital assets and where they are located. And you can start looking at the organization as a sort of beacon in the middle of the nodes, of the grid of nodes. It's exposed through API layers. And we believe it offers an opportunity for banks, financial institutions, and other parties to start bringing into the market a whole set of new services, which I would describe as data services. We have to start thinking of a bank not only as the place that I trust to store my money and that helps me transact money, but as an organization that I probably will also trust to store my data, my valuable data assets, and help me transact valuable data assets. And the sort of services that we can start thinking about here are things like personal data lockers, or personal tracking systems, or we can throw in big data and analytics to have a better insight in what our customers would like to have from us. Obviously, we have to think about security and identity and transaction integrity. Everything else that I've said so far, we have created in the prototype, so it's working code. It's real applications, so this is not futuristic thinking, it's working stuff. We know how to do this, but we have not implemented this in the prototype, the part of the security. Another way of thinking about this project is by looking at the use case. And I have a video with me. We have hired a video producer from Los Angeles to make a high definition quality video on what would be the typical use cases that this sort of geeky digital asset grid would enable. And I'll roll the video now. It's about 3 minutes.
Soon, performing a search will evolve into a new experience. You'll begin by describing what you want. Key attributes can be verified securely. This process, called intent casting, will enable 2 or more parties to instantly match their requirements. Verified users will have access to a greater range of information, such as maintenance history, accident reports, even the ability to request a test drive. A potential buyer can relay these requests to the seller, who can initiate a secure person-to-person transfer of data. Once the buyer and seller are ready to complete their transaction, the exchange of assets will be initiated through a secure bank application.
Thank you.
Beyond person-to-person purchases, there are exciting new ways to increase efficiency in business-to-business transactions. Janet, an investor, and her team use Zenapto, an application to find projects that fit their investment strategy. Their verified account status allows them to access project documents, review paperwork, and even close deals, regardless of their location. As Janet reviews the project, the site developer uses Zenapto to view his project's status and funding level. As soon as the investors are satisfied with the project, they signal their intention to invest at their desired amount. The developer will know instantly when his project has been funded. Thanks to Zenapto, these transactions can happen faster than before, enabling investors and entrepreneurs to create the future with confidence. Sharing data in this manner goes beyond monetary transactions. There are numerous practical applications for everyday use. Imagine being able to communicate secure medical updates directly to your doctor without having to physically return to the office. Vital signs can be tracked at home and digitally shared with your physician. From your doctor's secure dashboard on Fidor Bank's personal data store, she can monitor the progress of the treatment. Whether it be a request to make an appointment, change a prescription, or reply to a message, all of this can be done swiftly saving time while enhancing communication between doctor and patient. All of this can be possible through the Digital Asset Grid, a research and development project funded and led by Innotribe, the innovation division of SWIFT.
So everything that you saw in this video is real. So it's working apps. And the last app that you saw is developed by a bank in Germany, Fidor Bank. It's a real bank with a bank license. And they are now live with this personal data store, which comes as a default offering for all their online customers. So their online customers have a personal data store with drawers that they can define for health, for car insurance, etc., etc. This is live today. So what next? So this was an incubation project. SWIFT has decided not to continue this project. We're giving it back to the community. So it's now open sourced, so all the deliverables, the public deliverables are available for anybody who wants to take it on. And some people do take it on. So the concept of personal data stores has been labeled by Gartner as one of the top 3 technologies for 2013. And this is a company I encourage you to watch. Respect Network, you go to respectnetwork.com. And what Respect Network are doing, they were part of the prototype, so they're extending this prototype and bringing it into full production. A little bit busy slide, but in essence what they are doing, they have created what I would call the operating system for the cloud. So your personal cloud, your personal data store would run on an operating system for the cloud, and your personal data store could start sharing data with service providers, with CRM providers, etc. And start thinking, if you would have your address book or your personal information in your personal data store, if I would be able to open a channel with your Salesforce or your CRM system so that we have an end-to-end loop of real information of the customer, not deducted information from a Facebook profile. Because on Facebook, I could label myself as a woman of 25 years old and I would get advertising for bikinis in Miami. So here you would get the real information that the user has put and released in their personal data store. If Joanne is still in the room?
No, she's doing a meeting interview.
Okay. So the business model, Joanne, so the business model that these guys are thinking about is very simple to the credit card business model. In the credit card, you have an issuing bank and the acquiring bank of the merchant. So start thinking of, so the issuing bank is the bank at the side of the customer. So you could have a personal data store for the customer and you could have a personal or a business data store of the merchant. And there is a direct channel between those data stores. And so the whole environment is managed by a body to be invented. That would be a Visa for data or a MasterCard for data. And also there would be monetization of that data flow that flows through the system and everybody gets a cut out of it. These guys are almost live. So the beta is planned for the summer, and by the end of the year, there will be a public launch of this ID. Another way of looking at this, or continuation, is to start thinking about networks as grids. So if you start thinking about networks as grids, you start thinking about networks as dynamic fluid systems. Like you have, a very simple way of thinking of a network, it's a pipe and data flows from A to B through a pipe. But that's highly simplistic. It's really about conceptual functional networks that live on a physical network, and you can consider them as bassins of water, and maybe the capillarity in one bassin is going down to the favor of another bassin. But even that is a bit simplistic, because it's like in an ocean where you have currents of water, layers of water that are interfering with each other and creating currents. So we had the idea, what if you start thinking about networks as that sort of fluid systems, and you could do pattern recognition, analytics through those layers, what sort of intelligence would I get out of the network? So if you start thinking that way, we are starting to think in terms of early warning systems that would be interesting for heads of growth of a network or a company. so that I will discover unknown unknowns that exist in the network. Because usually what do you do when you make your forecasts? You do linear projections of the past. So you take your budget of last year and you slash 5% to it, or 10%, whatever, and that's the budget for next year. And you just anticipate that it will all continue the same way as it was in the past. By this sort of analytics, you can discover unknown unknowns in the network, and you can combine quantitative and qualitative data to inform scenario thinking on the long term. This is an image of a system called News Console, which is taking in 250,000 data sources, going from television channels to audio channels, etc. And what it shows here, this has been done for a financial institution. It shows on the right-hand side the typical view that the bank has for its system. It says it's payment systems, transaction systems, and in Europe there's something like SEPA. If we add the news feed to that, you will see that there's an as big ecosystem that is existing in mobile that you haven't seen or seen coming. Another way of looking at it is data cartography. So usually when we think about BI, business intelligence, we think about warehousing, data warehousing. It is basically a cube of data, and a programmer has predefined queries into that cube. But you're limited to the queries that the programmer has programmed in the program. So these is guys from Finland, FNA.fi, Financial Network Analytics. They also take into account the links between the entities in the cube. And they can do three-dimensional views on the graph and do simulations like, what if in the system this bank would fail? How would the payments flow? And which would be the next points in the network that would be hit if that sort of accident happens? They work for the Fed, they work for the Bank of England, they work for other big organizations. This is real stuff. This is not something I'm inventing here. This is also a very interesting guy. His name is Valdis Krebs. He is specialized in studying relationships between nodes in a grid. Check him out, Valdis Krebs. I'm getting a bit short of time. I'm almost through it, so remember this picture. The camel in the ocean is probably the biggest change that is happening today. And I would recommend you a book. This book is called Trillions. It's obviously about trillions of nodes on the grid. It's written by Marcus McManey. And Marcus McManey, together with his two founders, is running a company called Maya Consulting. They're based in Pittsburgh, and they are specialized in pervasive computing since 25 years. It's an absolute recommendation on what would happen if you start having trillions of nodes on the grid. What is the sort of architecture you have to think in? What is the ethical concerns? How you have to build privacy in all this? This is an absolute recommendation of a book. And with that, I would like to thank you and hope to talk to you later about this concept. Thank you very much.